Welcome back. Our state to the right is generated by rotating graph e to 0.4x y equals x plus 1 from x equals 0 to x equals 3 around the x-axis. Now y equals x plus 1, that's the easier one to understand. It's right here. And the e to the 0.4x, well, that's not going to be a straight line. It's going to be this one. Anyway, at x equals 0, they're both going to be 1. And then we got to figure out what kind of method we're going to use here. Well, in case you didn't happen to notice that there's literally a washer right there. You know, like from IKEA, when you have to put that stuff together. Bad memories, right? So they showed you there's a washer there. You could have tried to figure it out yourself. That is going to be the washer method. It's the first method you should always try when you're doing volume. If that doesn't work, then you try the shell method. But the way the washer method works is you always need a outer radius and an inner radius. Now for this washer here in the middle, we could say that there's an outer radius. I'm going to call that capital R, that goes all the way from the x-axis until the edge. So that's going to be your capital R. That's your outer radius. But if you want to talk about the inner radius, well, you're actually not going all the way there. You're only going up to where the hole of that washer would be. So this smaller distance here, that would be your inner radius, and the larger distance, that is going to be your outer radius. We're going to use a capital R to indicate that one. But then what you want to do is say, all right, this is going to be x comma x plus 1, because that's the formula for the y. And for the other point, you're going to say that that point is x comma e to the 0.4x. That's the y coordinate that you're supposed to be using for that other one. And it also might be helpful just to put that the coordinates down here are going to be x comma 0. 0 because you're on the x-axis. So if you want to write down something for the outer radius, you would just say it's x plus 1 minus 0, because that's how you get the length of a vertical line. So for that one, I could just say it's x plus 1 minus 0, which is, of course, x plus 1. So x plus 1 is your outer radius, so that's going to get squared. And your inner radius, by the same logic, is going to be e to the 0.4x. And that's also going to get squared. Now, I'm kind of covering up what the rectangle looks like here. Might be a little tough to see here, but that rectangle is right there. And it's going to have a very, very tiny dx thickness. So we're going to wrap all this with a dx. And now we need to know what the boundaries are. Well, they told us it's going to be happening from 0 to 3. So that means my integral goes from 0 to 3. So to get this started, it's going to be x squared plus 2x plus 1 minus e to the 0.8x. And now when you're taking the integral, it would be x cubed over 3 plus x squared plus x minus e to the 0.8x divided by 0.8. That's a funny one. You could have done a u substitution if you don't know how I did that. But it's kind of like chain rule where I take the derivative of the 0.8x and divide by it. That works as long as it's just something times x. Anyway, now you would plug in your 3. That would get you 9 plus 9 plus 3 minus e to the 2.4 over 0.8. And then we have to plug in our 0 and subtract. So it's going to be minus negative e to the 0 over 0.8. And that's going to turn into plus, oh my god, I'm in the way, aren't I? My bad. Plus 1 over 0.8, which is the same thing as 10 over 8, move decimal over 1 for each, which is the same thing as 5 over 4. And, yeah, whatever. 18 plus 3, 21. And then minus e to the 2.4 over 0.8. Now, over 0.8 is the same thing as times 5 over 4. So we actually just kind of did the work for that. And then, yeah, it's really not going to get much nicer than this. You could call it 21 5/4 or 22 1/4 minus 5/4 e to the 2.4. And now we're done. If you don't subscribe, I'm gonna go join TikTok instead.